When we configure our host failure response to restart VMs on other hosts, there are a couple of options that we have, and it has to do with the priority in which virtual machines restart. Now, being that this is a cluster-wide setting, if we don't create overrides for particular VMs, all of the virtual machines are going to restart on new hosts at exactly the same time. Okay? Actually, it goes down the list alphabetically and restarts them one at a time. Boom, 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 restarting all the VMs. Alphabetically, if you can believe that. All right, so fine. But I can change the restart priority if I want for other virtual machines by creating individual overrides. This will say, hey, virtual machine, I want this one to be started first. Make sure this gets started first. Then I'll start this other VM, and then the rest of the VMs can restart. So we can set up a default priority. By default, it's at medium, but we can set it all the way from highest to lowest if we want as a default, and then create individual overrides for an individual VM or a group of VM. Then we have to say, how is it that I know when to go to the next level or the next priority of VMs? There are some options there. How do I know when I'm ready to move from medium to low, or the highest priority to the high priority VMs? Well, we can do it when the resources for the VMs are allocated. I know that I'm going to be able to power on the VMs. Okay? When the VMs are actually powered on. OK, this VM actually got powered on. Move on to the next group of VMs. We can wait for guest heartbeats to be detected from VMware tools. This is going to take a little while longer because the guest operating system needs to boot. The services then start up. VMware tools is the last service really that starts up in most of these virtual machines. The heartbeat comes down. All right, fine. Okay, and finally, we can choose application heartbeats detected. All right, the default there is, by the way, when the resources are allocated. So as long as I know the VMs are going to be able to be powered on, I'll go ahead and move to the next level. So that's the default virtual machine restart priority. The last tab that we saw in the HA settings were advanced settings. There are a couple of options that we have here that you should be aware of. The first thing is about that isolation address. And we remember that the default host isolation address, this is the address that a host will ping as it's elected the master to make sure that the host itself is not isolated. Okay? The default is the default gateway. There's a setting there that says, hey, I don't want to use the default gateway. dos.useDefaultIsolationAddress, set it to false, and it won't use the default gateway. Okay? You can add other isolation addresses with dos.isolationAddress x, x being a number, 1, 2, 3, 4. And then you set up the IP address or fully qualified domain name of that isolation address. So you can add multiple isolation addresses there. Okay, and the other ones, the next one is a fault domain manager. How long am I going to wait before that 30-second isolation window occurs before I hit the next management network? Okay, do I want to set it to 30 seconds, which is the default, or more? The next two have to do with slot sizes. And it has to do with what happens on a virtual machine that does not have any reservations for CPU and memory. What should the slot size be? The default is 100 megabytes for CPU and 32 megahertz. Sorry, 100 megabytes for RAM and 32 megahertz for CPU. You can change that slot size. This is only relevant if you're using admission control by slot size. And here's finally how we can add virtual machine overrides. We remember we saw this same area when we were looking at the distributed resource scheduler to try to determine whether or not we should use a particular automation level for DRS. Well, if you scroll down a little further, you'll see all of the HA settings for virtual machine restart priority, adding additional delays, for permanent device loss and all paths down, we can set on a per VM level. The next topic we're going to look at here is called orchestrated restart. This is an interesting feature that has to do with virtual machines that happen to be running on the same ESXi host. That host goes down, fine, and I've got a whole bunch of virtual machines that are on that host, and maybe those virtual machines rely upon each other's services. Maybe I've got a web GUI, an application system, and a database. And they all have to be up and running. And the database has to be up and running first, and then the application system, and then the web GUI in front of it. Okay? And if the application system gets started before the database, well, then everything falls apart. All right. In that case, in the case that that host goes down, I can use HA orchestrated restart to set up the order in which those virtual machines are powered on. Okay? And we can choose to go from one VM to the next when the resources are secured, the VM is powered on, the VMware tools heartbeat is detected, or the application heartbeat is detected, just like we could when we set up the default restart priority. Okay? And we group the virtual machines into tiers. Okay? Tier 1, Tier 2, Tier 3 VMs. Okay? Tier 1 starts first. Okay? And then when all of those VMs have met one of these conditions up here, we can move to Tier 2, and then we can move to Tier 3, and so on. So in the event that, for example, the virtual machine A here is the web GUI, and virtual machine B is that application system, and virtual machine C is the database, we know that all of these VMs will start after VMC. So VMC comes up first, then VMB, and then finally VMA. Now, what happens if VMC never starts? Well, VMA depends on VMB. VMB depends on VMC. If one of these is missing, we don't create indirect dependencies. Okay? We don't say that VMA depends on VMB, depends on VMC, depends on VMA. We can't do that. We can't create the cyclical dependency. But also, VMA doesn't depend on VMC. So this order really has to be followed. And it also has to be set up so that all of these VMs are on the same ESXi host. If VMB is on a separate host, and A and C are on a different host, and that host fails, if the host that A and C are on, it's not like we will restart VMB after VMC starts and then wait for VMA. So all of these VMs have to be on the same host. So we need to configure VM to VM affinity rules to ensure that if this is a necessity for you, that all of these VMs stay on the same host. Now, like I said before, there's this button here that says Enable Host Monitoring with vSphere HA. And if you're doing any network maintenance that might fiddle with the management networks, then please disable host monitoring so that you don't get false positives for host failures. Finally, once HA is configured, you can click on the cluster, go to the monitor section, and find the summary tab for vSphere HA, where you can see the current status of the HA cluster. You can see who's the master host and how many subordinate hosts there are connected to the master, and what what state each of these hosts might be. Are we restarting the HA FDM agents, and so on. It'll tell you, is a host in standby or maintenance mode? Are there any hosts that are disconnected from vCenter, and so on. It'll tell you how many virtual machines are protected by vSphere HA and how many VMs in the environment for some reason are not protected by vSphere HA if we've, for example, disabled restart on particular VMs. So all of that is done on the monitor tab by selecting the summary link under vSphere HA. Now, we've looked at a couple of really nice cluster features, HA and DRS so far. And these two features are really nicely, tightly integrated. And let's look at how some of this integration works. Okay, so if we have a failover, HA is going to make sure that there are resources available on the hosts, on other hosts, right? And power on those VMs on other hosts. Well, DRS will make the choice of which VMs to power on which hosts in order to properly balance that cluster. That's a really nice thing. Now, we also might have an environment where our cluster has become fragmented in terms of virtual machines and their reservations. In other words, in aggregate, I might have plenty of unreserved capacity to support a big, large VM with a large reservation. But I don't have that capacity on any single host. Well, if the host with the big, large VM should fail, DRS will kick in and migrate VMs around to free up enough unreserved capacity on a single host to power on that virtual machine that had failed. A very, very nice integration between HA and DRS. Now, are there some situations where HA can be blocked by DRS from doing its thing? Yes, there are. And they have to do with, first of all, admission control, okay, as well as affinity rules. Okay, so if DRS affinity rules are set up as required affinity rules, these VMs must be on these hosts, and these hosts go down, HA can't restart the VMs. That makes sense. Okay, if HA admission control is disabled and there are VMs with reservations, and you have consumed all of the unreserved capacity in a cluster, okay, then HA will not be able to restart VMs whose reservations cannot be met. So make sure you use admission control, especially in the event that you have reservations, but it should also be there even when you don't use reservations, so you can be warned if in the event of a host failure, you're going to have some performance degradation across your VMs. A very, very important feature. Well, it's finally time to jump into the labs. And in lab number 26, we're going to test vSphere HA. And we're not going to use strict admission control with reservations here. What we're going to do is we're going to test this warning system that would occur in the event that I don't have enough resources available so that my VMs can perform properly. So you'll use that CPU busy feature again to generate load and watch as the warning occurs that says, hey, you might be fine right now, but in the event of a host failure, you're not going to be so good. All right, so that's our final lesson on vSphere HA. And now we know all of the recommendations around HA. We know about admission control. In fact, we know how to configure our vSphere HA clusters most of the time simply by leaving the defaults. But now you know why and what all those settings are all about. When we come back, we're going to have an introduction to vSphere fault tolerance, another great feature of a vSphere HA cluster. We'll talk to you real soon.